Once upon a time, the ocean was something to be navigated, something to pass through on the way to somewhere else. Now it's a source of real economic prosperity. 99% of global data is transmitted through underwater cables. $10 trillion of financial transactions go through the oceans every day. Just offshore renewable energy has gone from niche to very much day-to-day business. Our economic dependency on the ocean has changed. There's now some 2 million kilometres of aggregated underwater infrastructure, whether it's cables, pipelines, oil and gas wellheads. If we just rely on a linear approach, we have a ship on top, tracking along a cable, one cable at a time, looking for damage, maybe with 1 or 2 ROVs deployed from the same vessel. It would cost you in the region of $3 million to track several thousand kilometres worth of cable. But when you then consider the magnitude that you've got 2 million kilometres to be surveyed, and you calculate how many ships you would need, it's just a non-starter. How about we exponentially grow the capability of the ship by saying we're not going to track linear kilometres, but we're going to track square kilometres. What we need is a small craft operating underwater, operating at speed, and we don't just need 1 or 2, we need thousands. We need craft which are capable of a multi-mission approach, which are much more versatile. They should be able to travel freely, and they should be able to travel freely for some distance. And the reality is that right now the underwater industry is full of bespoke vehicles. They all are designed for a specific mission. They take some years to develop, but I don't think that's very future-proof. Can we look at what the automotive industry has done for cars, which is standardise on one architecture, rather than having one vehicle approach? Can we service the entire market and offer it the same power and propulsion solution and make it interchangeable across underwater vehicles? I've been 20 years designing bespoke underwater machines. As a small company, one of our strengths has been to look forward and see this is where the industry is heading. So we're focusing relentlessly on the technologies that make underwater craft move. That's the onboard power storage and the power delivery, the motor. We have built a class-leading power output for the battery pack. We've got the high energy density, but also a really reliable, maintainable battery pack, which is more suited to mainstream use. The biggest challenge for an underwater motor is keeping the seawater out and dissipating excess heat. We asked the simple question, what would happen if we let the seawater in to take away the heat? In our second generation underwater motor, we've solved both the leaking reliability problem as well as the heat transfer problem. With our technology, we will enable craft to travel much further on a single charge. So it won't just be major defence primes or underwater construction companies using the technology. A lot more craft will emerge, a lot cheaper, a lot more reliable, and a lot more suited to their function. We're now at the stage where the technology's been built, prototyped, it's been validated in a lab condition, but we are looking for a fundraise now so that we can validate it in real-world conditions. We've got customers based globally who will be the early adopters of our underwater battery packs and motors. We see the change in our company once our technology is brought to market, that we've got a rapid scaling over the next 5 years. We look to establish ourselves as the underwater powertrain provider of tomorrow.